9th Standard Chemistry, Chapter 1, Language of Chemistry, textbook by Prasad, page 14, exercise, question 4. Let's do Roman number 2. So out here, potassium, 2 atoms, but here only 1. So put a 2 out here. Chromium, 2 atoms, but here only 1. So put a 2 out here. Oxygen, 7 atoms, but here only 1. So put a 7 out here. But that makes hydrogen 14. So let's put a 14 out here. So hydrogen 14. Now only chlorine is left to be balanced. 14 atoms of chlorine. Here we have 2. 2 into 3, 6, total 8. Plus 2, 10. But I would like it to be 14. So what number should I put here to make the total 14? Think. Well, it'll be 3. Because 3 into 2 is 6. And 3 into 2 is 6. That's total 12. Plus 2, 14. So now it is balanced. You may do it in the long cut, where you write the names of the elements, the symbols. But once you've mastered balancing equations, you can do it directly as well. The next question 5. Calculate the percentage composition of potassium dichromate and potassium chromate. First of all, you need to know how to write the molecular formula of potassium dichromate and potassium chromate. For that, you need to learn the entire valency table so that you can use a crisscross method to derive the formulae. Potassium is K plus 1. Dichromate is Cr2O72 minus. So potassium's 1 valency goes here, but no need to write 1. And dichromate's 2 valency goes here. So that's how you get the formula. Similarly, potassium chromate. Now, we find the relative molecular mass, also called molecular weight. For that, we need atomic weight of each of these elements, and that will be given in the question. No need to learn it. 2 atoms of potassium, so 2 into 39. 2 atoms of chromium, so 2 into 52. 7 atoms of oxygen, so 7 into 16. You calculate and get the value, total 294 atomic mass unit. If this was in gram, I would call it gram molecular mass. Now, they want the percentage of each element. Potassium is 78 totally out of 294, so calculate the percentage. Similarly, calculate the percentage of chromium and oxygen. For oxygen's answer, you may add these two and subtract that total from 100% to get this answer. The total of these percentages should be 100%, or 99.99 is okay, 0.01 error is allowed. Similarly, do it for potassium chromate as well, the total RMM and the individual percentages. Now in the second part, they have given pie charts, and they are asking which one represents potassium dichromate and which one is potassium chromate. If you look at A, the percentage of potassium, the share of potassium is higher. Out of these two, which one has a higher percentage of potassium? This one. So definitely, this is potassium chromate and this is potassium dichromate. Next, page 116, worksheet 2, question 1, balancing equations. First of all, they have given word equations, so we will have to write it in the molecular formulae form, and then we'll balance it. Remember, whenever we have a metal, it's monoatomic, just Mg, not Mg2 or something. And it's an element, so the valency doesn't matter. Some formulae you need to remember. For example, phosphoric acid is H3PO4. And some you have to derive by the crisscross method, ammonium dichromate. For that, ammonium is plus 1 and dichromate is Cr2O72 minus, 2 goes down, 1 goes here, crisscross method, and that's how you get this. Gases like oxygen are diatomic. Nitrogen is diatomic, N2. N2, O2, Cl2, H2. Remember that, they can't exist alone. Even halogens like iodine, chlorine, bromine, they are diatomic. So once you've got the formulae right, now let's balance it. Mg is 1, Mg is 1, H is 2, H is 2, and sulfate. So it's already balanced. Next, here nitrogen is 2. This number outside the brackets means that 2 is for nitrogen as well as for hydrogen. So if nitrogen is 2, but here nitrogen is already 2. Next, hydrogen is 8, but here hydrogen is just 2, so put a 4 out here. Next, chromium is 2, but here chromium is already 2. How did I get this formula? Well, Cr was plus 3 and O was 2 minus, so crisscross. Oxygen is 7, and oxygen is 3 plus 4, 7. Yes, this 4 is for hydrogen and oxygen both. So now it's balanced. Next equation. Carbon is 1 and carbon is 1. Nitrogen is 1 and nitrogen is 1. Oxygen is 3, but here oxygen is 2 plus 4 plus 1, 5. So I would like to write a 2 out here. which makes hydrogen 2. Hydrogen is 2. But now nitrogen is 2. So let's put a 2 out here. Now oxygen is 3 into 2, 6. And here it is 4 plus 2, 6 plus 1, 7. Odd number, even number mismatch. So let's make this even. Let's put a 2 out here. There's no point writing a 3 out here, even though 3 into 3 will be 9, but hydrogen will become 3. And there's no way I can have an odd number of hydrogen atoms on the right hand side. So we'll go for even numbers. This makes hydrogen 4, so now write a 4. But that makes nitrogen 4, so write a 4. And now the only thing left is oxygen, so fingers crossed. 4 into 3, 12. 2. 4 into 2, 8 plus 2, 10. And 2, 12, balanced. But you've done cancellations while solving, so in exam make sure you write answer and copy the final answer without any cancellations. This one is easy. Just put a 2 out here and it's balanced. This one is already balanced. And so is the 12th one. You hope that you get such questions in exam. Well, keep dreaming. In question 2, let's do a few sums. 2.2. Copper is 1, copper is 1. Hydrogen is 1, but hydrogen is 2. Nitrogen is 1, but nitrogen is 2 plus 1, 3. Oxygen is 3, but oxygen is 3 into 2, 6, plus 1, 7, plus 1, 8. So I'll have to increase the oxygen here. First of all, let's equalize nitrogen. As I said, nitrogen was 2 plus 1, 3. But writing 3 here is of no use because it won't work out. Hydrogen cannot be an odd number. Hydrogen can only be an even number. So let me make nitrogen an even number, 2. So now nitrogen is 4. So put a 4 out here so that here also nitrogen is 4. 4 atoms of nitrogen. But now hydrogen atoms are 4. So put a 2 out here. That makes hydrogen atoms 4. Now oxygen is 4 into 3, 12. And here 3 into 2, 2, 6 plus 2, 8 plus 2, 10. That's less. I'll have to increase the oxygen atoms out here. Now I've got 3 options, 3 places where I can change the numbers and increase the number of oxygen atoms. This should be the last resort. I don't want to disturb so many elements together. These are odd numbers, so I would rather go for this one. Let's make it 4. So that way oxygen becomes 6 plus 4, 10 plus 2, 12. But then now hydrogen becomes 8. So I'll have to write 8 out here. I have no choice. But now nitrogen becomes 8. So how do I increase nitrogen? Well, I can increase it here, but notice that I have to increase oxygen also, because now oxygen is 8 into 3, 24, so I need a big increase. So it'll be better if I change the number here. And yeah, that will change copper too, but fortunately copper is alone, so I can increase it to whatever number I want in the end. So only if I put a number 3, will I get 3 into 2, 6 into 3, 18, plus 4, 22, plus 2, 24. So oxygen is equal. Not only that, I wanted 8 nitrogen, so I got 2 into 3, 6 nitrogen plus 2, 8 nitrogen. Hydrogen is also equal. So now the only thing left is copper. We'll just put a 3 out here and now it is balanced. If you make an error and you go to a big number, like you got 6, 16, 6, 8 and 4 as a final answer, which is also balanced by the way. But if you notice that every number is divisible by 2, then make sure you divide by 2 and then write the final answer. You will still get the marks. Now Roman number 4. Also notice that typically I am balancing oxygen at the end, although there is no hard and fast rule. So I see hydrogen is 1, but here it is 2 plus 2, 4. Also, oxygen is 4, 5, 6, 7. That odd number won't work. So let me put a 2 out here. So that's 4 plus 2 plus 2, 8. Even that won't work because this can never be 8. And anyway, hydrogen is now 4 plus 2, 6. So let me put a 6 out here. 6 into 3 is 18. Also notice that nitrogen has become 6. So let's balance nitrogen first. Yeah, I'm delaying oxygen balancing, hoping that it'll get balanced. Sulfur is 1 and 1. Only oxygen is left. 6 into 3 is 18 on the left hand side. And on the right hand side, 4 plus 2, 6 plus 12, 18, balanced. Next. Fe is 1 and Fe is 2. So put a 2 out here. But now sulfur is 2 plus 1, 3. And here it is only 1 sulfur. Oh, it's 3 sulfur, so that's balanced. Hydrogen is 2 and hydrogen is only 1, so put a 2 out here. Chlorine is 2 and chlorine is now 2, good. Oxygen is 2 into 4, 8 plus 4, 12. And here 4 into 3, 12, so now it is balanced. Next. Nitrogen is 1, but nitrogen is 1 plus 2, 3. Hydrogen is 4 and hydrogen is 3. So I'll have to increase this. Also chlorine is 2 and chlorine is less, so I'll have to increase this. Writing a 2 is of no use because 2 into 3 is 6 and there's no way I can make it 6. 3 will become an odd number. 4 might work. So let me put a 4 out here, making hydrogen 12. So that way I'll put a 3 out here, making hydrogen 12. But now nitrogen is 4 and here it is 3 plus 2, 5. And chlorine is 3, whereas it is 2. So I'll have to increase nitrogen here and increase chlorine here. What if I make it 4? So nitrogen is 4 plus 2, 6. Chlorine becomes 4, so I can put a 2 out here. So chlorine is 4 here as well. Hydrogen becomes 16. That's not going to help because I need some multiple of 3. And the only thing I can think of is 6 because 6 into 4 is 24 and 8 into 3 is 24. That's the only way hydrogen can be equalized. And that makes nitrogen 8, which is okay because here we have 6 plus 2, 8 nitrogen. But now chlorine is 6, so I'll have to change it to 3. Now that's the balanced equation. The 10th one. Na is 1 out here and Na is 1 out here. Cl is 1 and Cl is 2. So let's put a 2 out here. But that makes sodium 2, so put a 2 out here. Manganese is 1 and manganese is 1. Sulfur is 1 and sulfur is 1, 2, 3. So put a 3 out here. Now hydrogen is 3 into 2, 6. I got 2 plus 2, 4. So let's increase it. Now hydrogen is 4 plus 2, 6. Now the only thing left is oxygen. 2 and 3 into 4 is 12, 14 oxygen atoms. 2 into 4, 8. Plus 4, 12. Plus 2, 14. So now it is balanced. Next, potassium is 2 and potassium is 2. Chromium is 2 and chromium is 2. Oxygen is 7, so put a 7 out here. But hydrogen is 14, so put a 14 out here. But chlorine is 14. And here it is 3 into 2, 6. Plus 2, 8. Plus 2, 10. So put a 3 out here. And then it becomes 14. I think we've done this before. Now, page number 119. Write the formulae of the following compounds. The first one. See, again, you need knowledge of the valency table here. Potassium is 1 plus. Ferrocyanide is FeCN6, 4 minus. So 4 comes here down and 1 comes here down. We only crisscross the superscripts, not the subscripts. That remains as it is. Also, in the final answer, the plus and minus need not be written. Also, if the number is 1 out here, then no need to write it. Just the 4 comes here and the answer is this. Similarly, sodium thiosulfate. This was a 2 minus which came down here. Chromium sulfate. This was 3 plus and this was 2 minus. So crisscross. Cupric borate or copper 2 borate. Copper has a variable valency. It can be plus 1 as well as plus 2. So be careful about that. 2 comes here and 3 minus comes here. Calcium silicate. 2 plus and 2 minus. Cut. Whenever you can reduce it, you should. What if it was platinum sulfate? Platinum also has variable valency. Let's say platinum 4 plus. Now again, it can be reduced. 2 1s are, 2 2s are. So the answer is platinum SO4 2 minus. Now the opposite, 6.1. The formulae are given and you write the names. So this will be sodium ferrocyanide. Ferricyanide. Its valency is 3, not 4. So ferri, not ferrocyanide. Look at the valency table. This will be silver 1 thiosulfate. Don't forget to write valency number 1. Because if something has variable valency and you don't mention which valency it is, you will not get marks. If it was silver 2 thiosulfate, the 2 will get cancelled and you'll get the answer as AgS2O3. This 2 will go away. This is potassium dichromate, obviously. Calcium phosphate. This is sodium chromate. Like opposite of crisscross. Now question 8. Again, word equations are given. First of all, write it in the chemical formula form before starting to balance it. Notice that this was silver 1 oxide. If it was silver 2 oxide, 2 would get cancelled and the answer would be AgO. Anyway, we've got 2 atoms of silver here, so put a 2 out here. Hydrogen is 2, fine. Oxygen is 2 plus 1, 3 and 2 plus 1, 3, balanced. Roman number 4 is already balanced. And Roman number 6, well, here we have 1, 2 sulfur atoms, so put a 2 out here. But that makes hydrogen 4, so put a 2 out here. Now oxygen is 2 into 4, 8. 4 plus 2 plus 2, 8. And copper is 1 and 1, so balanced. Now on page 119, let's do question 9, balancing equations. Here they are. So Cu is 2 plus 2, 4, so put a 4 out here. Oxygen is 2, so put a 2 out here. But then copper becomes 6, so put a 6 out here. Sulfur is 1 and 1, so balanced. Now, potassium is 1, but potassium is 2, so put a 2 out here. But then manganese is 2, but your manganese is 1, so put a 2 out here. Here sulfur is 1 plus 1, 2. And here sulfur is 1, 2, 3, 4. So we'll have to increase this. What else? Hydrogen, 2 plus 2, 4. But here we have only 2. So put a 2 out here. So now hydrogen is also 4. Oxygen, well, that's 4 into 2, 8, plus 4, 12. And here we have 4 into 2, 8, plus 4, 12, plus 2, 14. So I'll have to increase oxygen out here. Also notice that sulfur is 1 plus 1, 2, and now sulfur is 1 plus 2, 3, plus 1, 4. So I'll have to increase sulfur as well as oxygen both. So let me increase this one. Putting a 2 out here is not sufficient, then sulfur will become just 3. So let me put a 3 out here. Sulfur becomes 3 plus 1, 4. But then hydrogen becomes 6. So let's put a 3 out here. But now what about oxygen? Well, oxygen is 2 into 4, 8. 3 into 4, 12. That's 20 oxygen atoms. And here I have 4. 2 into 4 is 8. So 8 plus 4 is 12. Plus 3, that's just 15. So oxygen is less. I'll have to increase oxygens. But which one should I disturb? What about hydrogen? Here I have 6 plus 2. That's 8. But here I have only 3 into 2, 6. So I'll have to increase hydrogen as well as oxygen. So definitely I'll have to increase the oxygen atoms by changing this number. So what number should I write so that here the total is, let's say 20 oxygen atoms. 4 into 2 was 8 plus 4, 12. So let's try an 8 out here. That will make it 20 oxygen atoms. So now oxygen is balanced. What about hydrogen? Well, hydrogen jumps to 16. So I'll have to increase hydrogen here. That's okay, I can increase hydrogen here, and don't worry about sulfur because sulfur is alone out here, so I can increase it to any number required in the end. So let's put a 5 out here because 5 into 2 is 10. 10 plus 6 is 16. And here also hydrogen is 16. So now the only thing left is sulfur. Let's count. 3 sulfur plus 5 sulfur, 8. So if I put a 5 out here, then 5 plus 2, 7 plus 1, 8. Roman number 6 is already balanced. Roman number 8, well, potassium is 2 out here, so put a 2 out here. Manganese is 2, but that's okay. 1 plus 1, 2. Oxygen is 8, that's okay. 4 plus 2 plus 2 is 8, so now it is balanced. Whichever sums are marked as read are easy, you can still do them. But it's not for homework. Whatever is not ticked, all the NB numericals which are not ticked are for homework. Now on page 120, let's do the question number 2. A 5-gram sample of a hydrate of BaCl2. So it has dot some H2O molecules. It's called water of crystallization. The dot is just a weak bond like this. It's not a multiplication sign. It was heated and 4.3 gram of the anhydrous salt remained, means without the water of crystallization. So what was the percentage of water in the hydrate? Well, out of 5 gram, if the salt, anhydrous salt was 3.9 gram, 4.3 gram, I mean, then the water which evaporated had a mass of 0.7 gram. So the percentage of water is water's mass upon the total mass, which comes out to be 14%. Now the 6th sum. 3 gram sample of sodium carbonate monohydrate is heated to constant mass. How much anhydrous salt remains? Meaning that H2O disappears. Then how much is left? We will use a unitary method here. First of all, find the RMM of sodium carbonate monohydrate. Sodium is 46, carbon is 12, total oxygen is 48, and water is 18. You see hydrogen plus oxygen is 1 plus 1 plus 16, that is 18. So out of 124 AMU, 18 AMU is water. So out of 3 gram of hydrated salt, how many grams is water? Cross multiply and get the answer 0.43 gram. So if that evaporates and the anhydrous salt is remaining, then how much salt is remaining? Well, subtract it. So 2.57 gram remains out of 3 gram, and the rest was water of crystallization. In the 7th sum, there's a 5 gram sample of copper nitrate .NH2O. So how many molecules of water of crystallization are stuck to this molecule is unknown. It's N. It could be 3, it could be 5, it could be 7, it could be 10, it could be any number, a fixed number, but it is heated. And 3.9 gram of the salt remains. So what is the value of N? Well, if the hydrated salt was of 5 gram and out of that anhydrous salt without water was 3.9 gram, then definitely the water part of it was 1.1 gram. Now find the RMM of copper nitrate without the water, and the RMM of N number of molecules is N into 18. So for every 188 AMU, we have N into 18 AMU of water. And for every 3.9 gram of copper nitrate, we have 1.1 gram of water. So you cross multiply and get the value of N, approximately 3. It should not be a decimal number. We can't have like 3.01 molecules of water. So that's the answer. Now the 14th question. Calculate the percentage of water of crystallization present in hydrated crystals of washing soda. Washing soda is sodium carbonate decahydrate. Well, that's easy. First find the total RMM including water. 10 into 18 is 180. Out of 286 AMU, 180 is of water. So the percentage of water in this molecule is 62.93%. Do you know, even you are around 60 to 70% water. Your cells, especially your brain cells, are mostly water. Is that why you're taking time to understand? 13th question. A sample of the iron ore Fe2O3 has 80% pure Fe2O3. Means 20% are impurities. Calculate the mass of iron in 40 tons of the iron ore. First of all, imagine that it was 100% pure Fe2O3. In that case, from 40 tons of iron ore, how much pure iron can you get? For that, we will use a unitary method. RMM of Fe2O3 is 160 AMU, out of which 112 is iron and 48 is oxygen. I'm ignoring any impurities right now. So for 160 AMU, 112 is iron. So out of 40 tons, how much iron? Cross multiply, you get 28 tons. And the remaining 12 tons is oxygen. But out of the 40 tons, already 20% is impurities. So the actual pure iron I will get will be less than 28 tons. So the iron I will get is actually 80% of this 28 tons, which is 22.4 tons. Next, page 121. Write the formulae. Calcium hypochlorite. Well, be careful about hypochlorite, chlorite, chlorate, and perchlorate. ClO with -1, then -2, then -3, then -4. Cross multiply, you get CaClO twice. Hypochlorous acid is HClO. Potassium plumbite, well, K is +1 and PbO2 is 2-, so crisscross, you get this formula. Nitrous acid is HNO2, also nitric acid is HNO3. Tetraamine zinc chloride, well, this is the formula. That's something you can't do by crisscross method, you have to learn this. Now, question 2. K2C2O4. This is not Cr, it's an error, it's just C2. And C2O4, 2- is oxalate, so the answer is potassium oxalate. And this shall be silver 1 thiosulfate. Next, let's do some balancing now. Question 5. And question 6 is again NB, that is for homework. First one. Copper is 1 and copper is 1. Carbon is 1 and carbon is 1. Oxygen is 2 and oxygen is 2. Balanced. 1 mark. Mercury is 1 and mercury is 1. Nitrogen is 1 but nitrogen is 2. So put a 2 out here. Oxygen is 3 into 2, 6. And oxygen is 4 plus 2, 6. Balanced. Carbon is 8. So put a 8 out here. Hydrogen is 18. So put a 9 out here. Oxygen is 16 plus 9, 25. But how do I write 25? It's odd number. So I'll make it perhaps 26 by writing a 13 and then increase this and then increase this. It'll be a long cut method. I have a shortcut method. I can make this 25. I'll just write 12.5 out here. So 12.5 into 2 is 25, so balanced. But of course, this is not the final answer. We can't have a fractional value, so multiply the whole thing by 2. So this becomes 2. This becomes 25. This becomes 16. This becomes 18. And check, now it is balanced. Carbon 16, 16. Oxygen 50 and totally 50. Hydrogen 36 and 36. Balanced. 1 mark. Fe is 1 and Fe is 1. S is 1 and S is 1. But O is 3 and here it's 2. So let's increase this to 2. But then we'll have to increase this to 2. Even number. But Fe is 2, so make it 2. But now sulfur is 2, so make it 2. But now oxygen is 4 plus 2, 6. So make it 6. Balanced. Next. Chlorine is 2, but chlorine is 3 plus 1, 4. So put a 2 out here. But then hydrogen is 3, so put a 3 out here. Now chlorine is 6, so make it 6. Balanced. Now sulfur is 1, but here sulfur is 1. Hydrogen is 2 plus 2, 4, so put a 4 out here. But then nitrogen is 4, so put a 4 out here. But then oxygen is 4 into 3, 12. And 4 plus 8, 12 plus 1, 13. So I'll have to increase this. 5 won't help. 6 might help. Let's try with a 6. So now nitrogen is 6, so put a 6 out here. Hydrogen is 6, so 2 and 2. Let's increase this one to 2. So that's 4 plus 2, 6. Now only oxygen is left. Sulfur is same. 6 into 3, 18. 4, 6 plus 12, 18. Balanced. Next, copper is 1 and copper is 1. Nitrogen is 2 plus 1, 3. Oxygen is 6, 7, 8, 9. And hydrogen is 2. Well, nitrogen is 3, so let's try with the 3. No, 3 won't help because hydrogen can never be 3. So let's start with a 4. So hydrogen is 4, so let's make hydrogen 4. But now nitrogen is 4, so I'll have to increase something. Let's make it 4 here. 2 plus 2, 4. Now oxygen. Copper is 1 and 1. Oxygen is 4 into 3, 12. 6, 7, 8 plus 4, 12. Balanced. Next, iron is 1 and iron is 2, so put a 2 out here. Sulfur is 2 plus 1, 3. Sulfur is 3. Hydrogen is 2. Hydrogen is now 2. Chlorine is 2. Chlorine was always 2. Oxygen is 4 into 2, 8 plus 4, 12. Oxygen is 12. Balanced.
Hi students, this is AJ sir. If you found this video useful, press the like button. Also, if you'd like to enroll for my test series or online lectures, email me or message me on Instagram. Check my description for more information.